Good morning, class.
Good morning, ma'am.
Today, we will discuss about clock arithmetic and see how it can be related to some concepts in number theory. Towards the end of the session, we will also have some artworks. Are you ready?
Yes, ma'am.
Take a look at the clock. Or do you have a watch with you? Make sure it's set at the 12-hour mode. Okay? Supposing it's 8 o'clock now, and we studied for 2 hours, what time would we end? Yes, Maritel?
We will end at 10 o'clock.
Okay, so that will be 8 plus 2 equals 10. Supposing at 10 o'clock, we studied for 3 more hours, at what time would we finish? Yes, Ronnie?
We will finish at 1 p.m.
Okay, 1 p.m. Supposing you went home at 3 o'clock, but then you were caught in a heavy 4-hour traffic. So 3 o'clock, 4-hour traffic, what time would you reach home? Yes, Kim?
7.
7 o'clock. Okay, if at 7 p.m. you decided to take dinner and watch television, what television shows do you normally watch at 7 p.m.? Yes, Karen?
I actually watch the news.
The news. Okay, suppose you took your dinner, watch the news, and that would take you around 2 hours or 3 hours. So you'll finish at what time, Jay?
We will end up at 10 o'clock.
Okay, 10 o'clock. Now, suppose you decided to sleep at 10 o'clock, and you normally sleep for how many hours? 8 hours? Okay, 8 hours. What time would you wake up the following morning?
I'll wake up at 6 a.m.
Okay, that will be 6 a.m. Now, take a look at this. 8 plus 2 equals 10. 10 plus 3 equals 1. 3 plus 4 is 7. 7 plus 3 is 10. But 10 plus 8 is equal to 6. What do you notice? Look at the sums. 10, 1, 7, 10, 6. If we continue the process, what would you notice about the sums? Yes, Mary?
They will range from 1 to 12.
Okay, let me write that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is actually a special set. Every time the sum reaches 12, we go back to 1. In abstract algebra, we have a special name for this if we change 12 to 0. This becomes the set Z12. Okay, so let me change 12 here and replace it with 0, but I'll put 0 in front. Okay, so if you take any two elements and add them, you'll go back to this set. All right. I told you that we will replace 12 by 0. So if in the clock, we start at 0, what time would it be after 7 hours? Yes, Renan. Okay, so after 7 hours, it will be 7. Again, starting from 0, after 31 hours, what time will it be? Yes, Rodel?
It will be 7 o'clock.
After 31 hours, we'll end up at 7 o'clock. All right. Now, what do you notice? Both 7 and 31 will end up at 7 in the clock. They have a special relationship. What relationship do you think exists between 7 and 31? How can we call these numbers? Yes, Fran?
I think 7 and 31 are congruent to each other.
Okay, so we say 7 is congruent to 31 modulo 12. In symbols, we write 7 is congruent to 31 mod 12. Let's take a look at the formal definition of congruence. It says there, integers a and b are congruent modulo n, where n is a fixed positive integer, if n divides the difference a minus b. Right? Let me write that in symbols. The first line goes a and b are integers, so a and b are elements of the set of integers. So a and b are congruent modulo n if, but we can write this as an if and only if clause because it's a definition. If n divides the difference a minus b, where n is a fixed positive integer. All right. All right. So let's check our example here. So which one is our a? Abigail? 7. Okay, so 7 becomes our a, and of course 31 will become our b. And what's our n? It will be?
12.
Okay, it will be 12. Okay, let's check. Our n is 12. So let's check if 12 divides a minus b. Our a minus b will be 7 minus 31. But what is 7 minus 31?
Negative 24.
Okay, it's negative 24. Does 12 divide negative 24?
Yes.
Let's recall the definition of the word divide. When do we say that a number divides a given number? For example, does 12 divide 24? How do we know if 12 divides 24? Yes, Ronnie?
When 24 is divisible by 11.
Okay, so 12 divides a given number here if this given number is divisible by 12. Or when you divide this number by 12, the remainder is 0. Or this number should be a multiple of 12. Okay, is negative 24 a multiple of 12?
Yes.
Okay, therefore, we can conclude that 7 is congruent to 31 modulo 12. Okay? Can you give me another pair of numbers which are congruent modulo 12? Can you think of a pair of numbers that are congruent modulo 12? Yes, Maribel?
2 congruent to 40 modulo 12.
Okay, let's check. Is 2 congruent to 14 modulo 12? Is 2 congruent to 14 modulo 12? By definition, let's see. Our n is still 12. So does 12 divide our a minus b now becomes 2 minus 14. So does 12 divide the difference 2 minus 14? What's 2 minus 14? 12. Does 12 divide negative 12?
Yes.
Therefore, we can say that 2 is congruent to 14 modulo 12. What if I have 29? To which element of Z12 is it congruent to? So we have here 29 is congruent to what? In modulo 12. This time, our missing is the letter B, the variable B. So, can you think of a number, any element from the set 0 to 11 that satisfies this congruence? Yes, Rebel?
5.
5. Let's check. Let's check if 5 is congruent or 29 is congruent to 5. Using the definition again, we will check if 12 divides which one?
29 minus 5.
29 minus 5. Does it divide? But 29 minus 5 is?
24.
24. Does 12 divide 24?
Yes.
there's an easier way to look for the missing b. Can you think of an easier way on how to arrive at the missing b? What if I ask you to divide 29 by 12? What remainder would you get? 5. Here, what if I ask you to divide 14 by 12? What remainder would you get?
2.
Actually, the easier way to look for the number or the letter B here is to divide A by N and get the remainder. That will give us our B value. But take note, 29 is congruent not only to 5. Can you think of other numbers to which 29 is congruent to in modulo 12? Yes, Ronnie?
29 is also congruent to 17.
Okay, let's check. Is 29 congruent to 17 modulo 12? Meaning, does 12 divide the difference 29 and 17? What's the difference of 29 and 17? 12. So 12 divides 12. Therefore, this is correct. What if I ask you, is 30 congruent to 17 modulo 12? Let's check. Does 12 divide the difference 30 minus 17?
No.
Let's see, what's 30 minus 17?
13.
13. So this does not divide. So we write 30 is not congruent to 17 modulo 12. Okay? Now, let's change our modulus 12 to, say, 5. Right? So what do you think will be the elements that we will be considering? If in Z12, how many elements did we have? We started from 0, 1, 2, going to 11. That's 12 elements, all right? What if we restrict ourselves to Z5? How many elements do we have? 5. So we start again from
0, 1, 2, 3, 4.
All right. Can you give me two numbers that are congruent to each other, modulo 5? Two numbers. Or can you just give me any two numbers, Philip? And we'll see if they are congruent to each other, modulo 5.
2 and 12.
Okay. Is 2 congruent to 12? Modulo 5. Let's see. So this time, instead of 12, we use 5. So let's check if 5 divides the difference 2 minus 12. Does 5 divide this difference?
Yes.
Does 5 divide negative 10?
Yes.
Therefore, we can say that 2 is congruent to 12 modulo 5. Okay. How about 13? Is 13 congruent to 2 modulo 5?
No.
How do you know? What numbers did I just say?
13.
Okay, let's check. Is 13 congruent to modulo 5? Let's check. So that means we'll check whether 5 divides the difference 13 minus 2. Okay. Does 5 divide 11?
No.
So therefore, 13 is not congruent to 2 modulo 5. All right. Can you go back to modulo 12?
Yes.
Okay. All right. Earlier, we did some additions, right, with the hours. Okay. So that means we can perform the operation addition on modulo 12. Can we fill out this table?
Yes.
All right. I'll start with the first row. 0 plus 0 is?
0.
0 plus 1?
1.
0 plus 2?
2.
So do you see a pattern?
Yes.
So all I need to do is copy them. Okay, I will copy them all here. And I'll start with this column again. 1 plus 0 is 1. 2 plus 0 is
2.
3 plus 0 is
3.
Okay, do you see a pattern again?
Yes.
So all I need to do is
Copy.
Okay, copy since this is 0. Right? 7, 8, 9, 10, and 11. Now I need volunteers who can fill the table up. Who can fill the first row? Anyone? Yes, Ruby. Please fill up the next row. How about the following row? Yes, Jay. Next row, please. Mary. Do you see a pattern?
Yes.
Is there an easier way of writing the Can you have Abigail?